Hey there and welcome. Today, we're going to pull back the curtain on the hidden code that literally runs our world. It's in everything from our cars to our coffee makers. It's called embedded software, and trust me, it is everywhere. So let's dive right in. Okay, so to get us started, let me ask you something. What could your car, your coffee maker, and a high-tech medical infusion pump possibly have in common? I mean, they seem totally different, right? Well, they all share this one secret ingredient, a tiny, specialized brain that's running a very specific set of instructions. And by the end of this, you're going to know exactly what that is. So here's what we're going to cover. First, we'll nail down exactly what this hidden software is. Then we'll look at how it's actually made, and we'll compare it to the apps you use every single day. After that, we'll uncover the unique challenges developers face. And finally, we'll explore how you could get started in this absolutely fascinating field.
All right, first up, what exactly is this invisible intelligence? Let's go find the code that's hiding in plain sight all around us.
You know, at the heart of it all is something called an embedded system. The best way to think of it is like a device's central nervous system. It's this tight combination of hardware and software that's designed to do just one job, and do it perfectly. This isn't like your laptop that can do a million things. It's a highly specialized brain built for one dedicated function. And once you know what to look for, you start seeing it absolutely everywhere. It's the code that runs the braking system in your car. It's what manages your smart thermostat. It tracks your steps on your fitness band. It's inside the robots on a factory floor and the patient monitors in a hospital. Seriously, you've probably interacted with dozens of these systems before you even finish your morning coffee. And the sheer scale of it all, it's just staggering. This is not some niche technology. We are talking about over 10 billion active embedded devices around the globe. That's more than one for every single person on the planet. It isn't just a part of our tech world. In so many ways, it is the foundation.
Okay, so we get what it is, but how does this software actually come to life? Let's take a look at the journey from a simple idea to a fully functioning device.
You know, the whole process is incredibly deliberate. It all starts with defining exactly what the device needs to do, no more, no less. Then, developers figured out how the software is going to talk to all the physical parts, the sensors, motors, buttons, you name it. Then comes the actual coding, and that's followed by some seriously rigorous testing, because in a lot of these systems, failure is just not an option. And finally, the code gets installed or deployed right onto the device's hardware. Now, to write this kind of code, developers need a pretty specific set of tools. C and C++ are the absolute kings here, mainly because they give you direct, fine-tuned control over the hardware. When you need every last drop of performance, you might even use assembly. And lately, you're seeing languages like Python pop up for quick prototypes, and Rust is gaining a ton of ground for building safer, more secure systems. And if you want to see just how complex this can get, look no further than a modern car. It's not run by one computer, it's a whole network. A single car can have over 100 of these little embedded control units, and each one is a tiny, specialized brain managing something different, from your engine timing all the way to your touchscreen display.
Okay, this next part is super important. How is this stuff any different from the apps you have on your phone or your computer? This is one of those real aha moments that'll help you see why embedded development is its own unique universe.
So here's the bottom line. Traditional software, like your web browser or a video game, it runs on powerful computers with tons of memory, and it's built for all sorts of general tasks. An embedded system is the complete opposite. It's designed for one single, specific job. It has to talk directly to physical hardware, and it has to do all that with very little memory and power. Everything has to be incredibly efficient, and a lot of the time it has to respond in real time, where even a millisecond can make all the difference. And that's exactly why this is so much more than just coding. Embedded development is a true hybrid field. It's where software engineering smashes right into electronics. You can't just write code, you have to think about how that code will behave on very specific and often very limited physical hardware. Well, that unique blend of skills leads directly to some pretty unique challenges. So let's talk about the hurdles that developers have to clear when they're building software for the real physical world. So developers are up against a few key things. First, with very limited resources, they have to squeeze every last bit of performance out of every line of code. For systems where safety is critical, like a car's airbag, that software has to react instantly. A delay of a few milliseconds could be catastrophic. And since every piece of hardware is a little different, you can't just copy and paste code from one device to another. And of course, as more of these devices get connected to the internet, Keeping them safe from cyber attacks has become an absolutely massive job. Now, if all of this talk about constraints and challenges actually sounds kind of exciting to you instead of scary, you might be wondering, okay, how could I get started? So for our last section, let's map out a practical path for anyone who's curious about getting into the world of embedded systems.
So your journey really starts with the hardware itself. You got to understand things like microcontrollers and basic circuits. Then you'll want to really master the core languages, especially C and C++. And honestly, the best way to learn is by doing. So getting a simple development board and just building small projects is absolutely key. From there, you can learn how devices talk to each other and eventually dive into real-time operating systems, which are the brains behind more complex, time-sensitive devices. And here's why this is such a big deal right now. This isn't just for fun. The Internet of Things, or IoT, is absolutely exploding. We're on track to have over 25 billion connected devices really soon, and what that means is the demand for skilled engineers who can actually write the code to make these things work is just going to keep on growing. It's a career path with enormous potential.
So I want to leave you with this final thought. For the longest time, our digital lives have been stuck on screens, on our phones, our laptops, but the next huge wave of technology is being woven directly into the fabric of our physical world. That future is being built line by line with embedded code. The only question is, who's going to write it? Thanks for joining me.